Hello students, so we are solving OHM'S chapter 32 questions, and student, you can find out link of solution of all rest questions of this chapter below in description box, or you can also go in playlist. Student, we have also solved questions of NCERT class 12 chapter 3 current electricity, so you can also find link of solution of all those questions of NCERT below here in description box. So please, if any student is new on this channel, subscribe this channel, share this channel, and so let us start our today's class. Student, question number 33. This question is saying find the currents through the three resistors shown in the figure. You can see here there are three resistors in the circuit, and we have to find the current flowing through all these three resistors. Student, current from this resistor will be zero. How? Very clear, because this resistance is short circuited, so no current will flow through this resistance. So current flowing through this will have zero value. Now for these two resistors, suppose the current flowing through these two are obviously I, and so the same current will flow like this I current. Okay, now you can find out value of I by two methods. In fact, there may be a lot of methods. We are going to see just two methods here. How to find the value of I? You can see I equals to, from Ohm's law, net EMF divided by net resistance. Okay student, now here you can see what will be the value of net EMF. 4 minus 2 volt divided by net resistance. Clearly these two resistance are in series, because same value of current is flowing through these two resistors, and so the equivalent resistance will be 4 plus 6 ohm, and so from here 2 by 10 this becomes 0.2 ampere is your answer. Means the current flowing through this 4 ohm resistor as well as the current flowing through this 6 ohm resistor will have 0.2 ampere value. Okay student, what may be the second method? Just see, it's very clear that current flowing through this 4 ohm resistor is 0 due to short circuiting. Okay, now for finding the value of I, you can also apply KVL in this loop. Let this loop is P Q R S. Okay, now from KVL, Kirchhoff's voltage law, in loop P Q R S P. Okay, we are applying KVL in loop P Q R S P, and suppose we move like this, okay, clockwise direction. So now write down potential across all resistances and including all EMF, and equals to 0 from concept of KVL. So current potential difference across this resistor will be 4 ohm resistance. I current is flowing, so this will be 4I plus 6I plus 2 volt, because we are facing its positive plate, so plus sign we will take, and this again we are now facing minus negative plate, so minus sign, and minus 4 equals to 0, and from here you can see this 10I minus 2 equals to 0, and so I equals to 0.2 ampere. Okay student, now let us move to question number 34. Question number 34, student. Figure shows a part of an electric circuit. There is a circuit given for this question, and the circuit is like this. Okay, now let the value of all these three resistance has been given: 10 ohm, 20 ohm, this is 30 ohm, and this is point A, point B, point C. Okay, now the question is, figure shows a part of an electric circuit. The potentials at the points A, B and C are 30 volt, 12 volt and 2 volt respectively. The potential of this point A is 30 volt, potential of this point B is 12 volt, and the potential of this point C is 2 volt. Okay, respectively. Find the currents through the three resistors. Student, we have to find the value of current flowing through these three resistors. Now how we will think? This is important. How will we think? Student, for finding the value of current through this resistance, from Ohm's law, you will have to require to know the potential difference across this resistance. If you find the value of potential difference through across this resistance, then from Ohm's law V equals to IR, you can find the value of current equals to potential difference divided by 10 ohm. Means, and for finding the potential difference across this, you will have to require to know the potential of this point, because the potential of this point is given, and so the potential, if the potential at this point is B, then the potential difference across this resistance will be 30 minus B. Okay, means finally anyhow, and similarly you can discuss, you can say, for finding the current through this, you will require the value of potential of this point, so that you can find the value of potential difference, and dividing that potential difference by this 20 ohm, you can find the value of current flowing through this 20 ohm resistance, and similarly for 30 ohm. Means anyhow, the important thing is you have to find the value of potential of this point. So let this potential is V. Let this potential is V. So from KCL, Kirchhoff's current law, from KCL, we are applying Kirchhoff's current law from KCL. Okay, you can write out the all outgoing currents. Write down the value of all outgoing currents and equals to 0. Means the value of outgoing current through this section will be V minus 30, V minus 30 divided by I equals to V by R from Ohm's law. V minus 30 divided by resistance 10. Okay, plus now this is the outgoing current through this section. Okay, now we are going to write the outgoing current through this section, and this will be V potential difference divided by 20 ohm. So V minus 12 volt, this is your potential difference. V minus 12 divided by resistance is 20, plus now outgoing current through this section will be V minus 2 divided by 30 equals to 0. Sum of all outgoing current equals to 0. From Kirchhoff's current law, when you will solve this, this is 60, this is 6V minus 180 plus 3V minus 36 plus 2V minus 4 equals to 0. This is 6V plus 3V plus 2V. This is 11V minus 180 minus 36 minus 4 minus 40 minus 220, this side 220. So the value of B is 20 volt. Okay, now easily you can find out the current flowing through all these resistance. Let the value of current through this 10 ohm resistance is I1. So the value of I1 will be obviously current will flow like this, because now its value is 20 volt, and so current will flow from high potential to low potential. So the value of I1 will be potential difference 30 minus 20, I equals to V by R divided by 10 from Ohm's law. This will becomes 10 by 10 equals to 1 ampere. Now let the current flowing through this is I2. So I2 will be 20 minus 12 potential difference divided by resistance I equals to V by R, resistance 20 ohm from Ohm's law. This becomes 8 by 20, this becomes 4 by 10, this becomes 0.4 ampere. Okay, and similarly if the current flowing through this resistance is I3, so I3, value of I3 will be 20 minus 2 divided by 30. 20 minus 2 divided by 30, this is 18 by 30, this is 3 by 5, this is 0.6 ampere, and so these are our final answer. Okay student, so let us move towards question number 35. Question number 35, student. This question is saying each of the resistors shown in the figure. Again, you have to give a circuit for this question number 35, and there are two circuits. In fact, there are two circuits for this question, student. let this is resistance A, this is B. Okay, now and the second circuit for the same is okay. Now this is your resistor A, this is B, this is C. Okay, now the question is saying each of the resistors shown in the figure has a 10 ohm resistance of 10 ohm, and each of the batteries has an EMF of 10 volt. Okay, 10 volt battery, 10 ohm resistance. Okay, 10 volt, 10 ohm, 10 ohm. This is your 10 ohm, this is 10 volt. Now find the currents through the resistors A and B in the two circuits. For these two circuits we have to find the value of current flowing through resistor A and B. Just for this circuit, if we talk about for this circuit, then very easily you can understand the value of current flowing through this resistance. Since battery directly, this battery is connected having EMF 10 volt across this 10 ohm resistance, means simply this circuit is what? Particularly this section is what? Obviously like this, and you can understand this is the simplest circuit, and in this case you can find out the value of current which will flow like this, having value I equals to V by R, 10 volt divided by 10 ohm resistance. This is 1 ampere. Very simple. So the value of current through this resistance, will be what? 1 ampere. You can find out here IA is the current flowing through this resistance A. This will be 10 by 10 equals to 1 ampere. Okay, now for finding the value of current through this resistance, let the value of current through this resistance is IB. You can find out, you can write the direction of current, as we are assuming the value of current is IB. You can assume direction of IB, current flowing through this way, no problem. If at last you find the value of current in negative, it means the direction you have assumed is opposite to the actual direction. Okay, now IB, for finding the value of current IB, you can see here in this loop, since in this loop we have all known values, only unknown values is IB. So if we apply KVL in this loop, Kirchhoff's voltage law in this loop, then from there we can easily find out the value of IB. Let this loop is P Q R S T U. Okay, now from KVL in loop, in which loop? P Q R S T U P. Okay, now we are applying KVL, Kirchhoff's voltage law, Kirchhoff's loop law in loop PQRSTUP. Okay, now potential across this is 10 into I, current flowing through I, plus IB into 10. Okay, now negative plate. Okay, we are moving like this, minus, so we will take minus sign, minus 10 volt equals to 0 from KVL. Now here you can see this 10 plus 10 IB minus 10 equals to 0. 10 minus 10, 0, means 10 IB equals to 0. So the value of IB, means current flowing through resistor B, will be 0. Okay student, now let us move to second part. For this part student, okay, now we have to find the value of again current flowing through resistor A and B. From A, again you can see, in fact this part is exactly the same, just rotate this part vertically, equivalently this part is. So from here, if current flowing through A is IA, so this IA will be, again you can understand, I equals to V by R, exactly this side, this way, 10 by 10 means 1 ampere. And similarly you can understand student that the current flowing through this resistor C will be also like this, and its value will be also IC will be exactly same situation, 10 by 10, 10 volt by 10 ohm. From Ohm's law means you can write IC 10 by 10 equals to 1 ampere. Now student, now we are knowing current flowing through this resistance, current flowing through this resistance, and we have to also find the value of current through resistance B. Let this is IB. So again, what will we do? Better to apply KVL again in this loop. KVL in this loop. KVL in this loop. Student, what will happen in this loop? We are knowing all the values IA, IC, value of resistance. Only unknown value is IB. Obviously, we will find out the value of IB from there. Now, from KVL in loop, let us, this loop is, this is point P Q R S. So the loop is P Q R S P. Okay student, now okay, let us move this way. Okay, we are moving this, so the potential difference across this will be IA into 10 IA. Now this again, we are moving this side, current is flowing this way, so we will take minus sign, and this will be 10 IC minus 10 IC. Now again we are moving this side, current is flowing this side, so this potential difference across this will be 10 IB equals to 0. Okay student, now from here this is 10 IA. The value of IA is 1, minus 10 into value of IC is also 1, minus 10 IB. We have to find the value of IB. From here 10 minus 10 IB equals to 0. This is 0 minus 10 IB equals to 0. This is 10 IB equals to 0, and so IB equals to 0. Means again here the value of current flowing through resistor B will be 0. No current will flow. Okay student, so student, we meet in next class with solution of rest questions. Thank you.